Okay. So, just to repeat that again, we either knew it was going to open left and right or up and down. So, you just look at which variable is positive. In this case, the x was positive, the y was negative. So from the center, you go in the x direction, and those are your two vertices, and it curves closer and closer to the asymptotes on either side. Okay? Now, the only thing left is I can ask you where the foci are. Okay? What was the formula for finding the foci when it was an ellipse? Squared minus b squared, right? So ellipse was plus, but it was a squared minus b squared. Hyperbola is a minus, so it's a squared plus b squared. Pythagorean theorem. Okay? So you have, actually, let me finish this. Draw your asymptotes through the corners, and then from center, go in the direction of the positive variable to find your two vertices. Graph to the asymptotes. Okay? All right, so now that was just how to graph it. So now to find the foci, you're going to use c squared is a squared plus b squared. So that becomes c squared equals 16 plus 25, right? So c squared equals 41. So c is the square root of 41. Now, what is c always? It's the distance from the center to a focus. Okay? So, here's the center. The foci are going to be inside. So they're going to be here and here. All right? So we're going to go to the right, square root of 41. Well, that is between the square root of 36 and 49. So that's between 6 and 7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and 7. So somewhere right here. Somewhere right here. What would the coordinates of this focus be? It would be, the y coordinate's 5. The x coordinate is going to be -2 plus the square root of 41. This one is going to be -2 minus the square root of 41, 5. Mm-hmm. Yeah, so the focus is a point. You're just finding the point. So you have two of them. No. X is -2 plus the square root of 41. Because it's got to be the square root of 41 away. So this distance has to be square root of 41. Okay? The only other thing I could ask you is, what is the slope of the asymptotes? Or the equation of the asymptotes? And that is actually a question from way back, because you know 2 points on it. So you can find the slope with your slope formula. Or you can find the equation of it by finding the slope and then plugging in to slope-intercept form to find the intercept. Okay? And whatever this slope is the same but negative. So you only have to do it for one. Okay? and the slope ends up being either a over b or b over a. Okay? It's whichever one is y over whichever one is x. So in this case, it would be 5 over 4. So this would be positive 5/4, this would be negative 5/4, would be the slope. But if you forget that and just have the 2 points, you could find the slope of it. Okay? All right, let's do a couple more. All right. So let's say I ask you to graph okay? So you guys tell me, what am I going to do first? Center is where? 3, negative 2. Yeah, because x is 3, y is negative 2. So there's your center. Okay, then what? So you tell me, what do I do from that point? Well, major and minor has to do with ellipse. So you got to tell me for what? Four in the y direction. So I go up 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. Okay. You go left and right 3. So 3, 3. Okay. Then instead of drawing an ellipse, you draw a dotted rectangle. Okay. Then you draw the asymptotes through the corners. Okay. Then what? Are my vertices up and down or left and right? Up and down y. Y is positive. So from the center, we go up to a vertex, down to a vertex, and graph it curving to the asymptotes. So it's the point based on the Okay. Only thing left is I could say find foci. All right. C squared is a squared plus b squared. C squared is 16 plus 9. C squared is 25. So C is 5. So what? So we're going to go up 5. 1, 2, 3, 4, 5. Down 5. 1, 2, 3, 4, 5. So the foci would be at 3, 3, and 3, negative 7. That's it. Okay. Only way this can get any harder is if I didn't give it to you in standard form, and you'd have to complete the square to get it in this form. Okay. We'll do something like that, but I want to go the other direction. I want to give you a hyperbola, and you give me the graph of one, and you tell me the equation. Okay? So let's say I gave you this hyperbola and said, write the equation for the graphed hyperbola. Okay. Okay. So you kind of do it in the reverse order, or I mean, kind of backwards from the same order, but you're finding out things in the way you would graph them before. So the first thing we graphed was the center. So first thing we have is the center. Okay, also, which is going to be positive, x or y? Y, because it opens up and down. So we're going to have y minus something squared minus x minus something squared equals 1, right? Well, the center is at 1, 1, so it's x minus 1, y minus 1, right? Okay, so here were our asymptotes, right? So our rectangle looked something like this. So how far up and down from the center did we go? 2. In the x direction or y direction? In the y. So under your y goes 2 squared, which is 4. Okay? Because that distance was 2. 2 squared goes under y. Problem is we don't know this distance. Right? So we knew our a squared. We don't know our b squared. But what else do we know? There's a focus at 1, 5, and there's a focus at 1, negative 3. So what is c? We knew that a was 2, so a squared was 4, which goes there. We don't know b, so we don't know b squared, but we know that c is what? 4, because it's the distance from the center to a focus. So that's 4 or that's 4. So c is 4, right? So we know that c squared is a squared plus b squared, right? So that means 4 squared, a squared we already know is 4 plus b squared. So 16 is 4 plus b squared. So 12 is b squared, right? Well, we actually don't even care what b is because what goes in the formula is b squared. So there's no point in solving for b unless you needed to graph these asymptotes to know what b was, because what's going to go here is b squared, which is 12. And that's your answer. Okay? All right, let's do one the other way, or one where I give it to you in non-standard form, and you do it in standard. Okay? So, write in standard form. Okay? All right, I'm going to teach you in a second how to know this is a hyperbola, but for now, just know that it is. Okay, I'm going to teach you in a second how to distinguish between them. But, okay, so what you need to do is complete the square for x and for y. All right, so what I'm going to do is put my x squared first because it was positive. Then I'm going to put my x. Then I'm going to leave a space to complete the square. Then I'm going to put my y squared. Then I'm going to put my y. Then I'm going to leave a space to complete the square. Take the constant to the other side, which makes it positive 36. Okay? Now, typically, when you're completing the square, you want this to be 1x squared, right? So you would want to divide everything by 25. But we need this to be 1y squared as well. And if you divided everything by 25, that would really mess you up here. So what you have to do, instead of dividing everything by 25, you factor out a 25. So we're going to factor out a 25, and we're left with x squared plus 4x space. What are we going to factor out here? A negative 4. And we're left with y squared minus 6y space. Okay? Now we complete the square. So what do you do here to complete the square for x? So take positive 4, divide it by 2, so that's positive 2. Square it is plus 4. But we didn't just add 4. We added a 4 inside of parentheses that had a 25 on the outside. So we really added 100. So over here, we have to add 100. Okay? Then what about here? So negative 6 by 2, which is negative 3, square it is plus 9. But we didn't really add 9. We added 9 in a parentheses with a negative 4 out. So we really subtracted 36. Okay? So now we have 25. What is that squared? X plus 2. Minus 4, what is this squared? Y minus 3 equals 100. Right? The only thing left is to be in standard form, it's got to equal 1. Right? So, divide everything by 100. $25 cancels with 100 and leaves 4. 4 cancels with 100 and leaves 25. And so your final answer is x plus 2 squared over 4 minus y minus 3 squared over 25 equals 1. And from that, you could graph it, just like we had the other ones. Okay, graph it, find the vertices, find foci, find the asymptotes, all those things. Okay? All right, so that's all from 7.5. 7.6, which I'm going to talk about 7.6 today, but not assign the homework till tomorrow. Okay? But 7.6 is putting all this together and determining which conic section you have from an equation. Okay? So, I don't know what to call it because standard form is what we've been doing, where, you know, you've got it in the form where you can see what the center is and what the radii are and all that. That's standard form. But I guess we could call it normal form. Just there is a form for all conics where you have ax squared plus by squared plus c times x plus d times y plus e equals 0. Really, and so we'll call that normal form. That's not a term used in your book. That's one I made up just right now. Okay? Really, that's a fancy way of saying get everything on one side equal to 0. Okay? All right? Now, any of these could be 0. If there were no x squared in the equation, that would have your a would be 0, and you would just have that, right? All right, so every conic can be written in that form. So let's talk about when is it a parabola, when is it a circle, when is it an ellipse, when is it a hyperbola, okay? It's a parabola. Anybody have a guess? It's a parabola when there's only x squared or y squared, not both. Okay? Now there can be an x term and a y term. In fact, there probably will be. But there is either only x squared or y squared. Okay? Then we know go back and how to get it in vertex form, find the vertex, find the directrix, find the focus, find the length of the lattice rectum, all those fun things. Okay? All right, so that's a parabola. So everything after here, there is x squared and y squared. Okay, because if there's not, it's a parabola. But everything else, there is x squared and y squared. For a circle, there is x squared and y squared. And they have the same coefficient. Okay, so it would be like if you just had x squared plus y squared plus 7x plus 10y plus 15. Okay, where they both had a coefficient of 1. But it also works if you had 8x squared plus 8y squared plus other things. Okay, so you have an x squared and a y squared, and they have the same coefficient. That's a circle. Which makes sense. Your x squared and your y squared, it's a constant radius. So in the x direction and the y direction, it's constantly the same. So they have the same coefficient. All right? For an ellipse, you have x squared and y squared. I don't really have to write that every time because that's true for everything except the parabola. You have x squared and y squared, different coefficients, but same sign. So what I mean by that is the coefficient of x squared and the coefficient of y squared, they're different, but they're either both positive or both negative. Okay? But you may think, well, I thought in an ellipse they had to both be positive. Well, if they're both negative and you multiplied the whole equation by -1, they'd both be positive. Okay? So technically they're both supposed to be positive, but if they're both negative, you could get that really easily. Okay? So that's an ellipse. And then finally, hyperbola that we just learned today. What do you think that one is? So x squared and y squared. And coefficients I don't know why the camera just went blank. Okay. Coefficients have different signs, meaning one is positive, one is negative. Okay? So, that's really it, and it doesn't get more complicated than that. The thing that's complicated is what we've already learned, is once you figure out which one of it is, you have to get it in standard form, okay? Now, they all require you to complete the square. A parabola, you solve for the one that's not squared. So if you had an x squared, you're going to solve for y and complete the square for x, okay? If you have a y squared, you're going to solve for x and complete the square for y. For a circle, it's, remember, x minus h squared plus y minus k squared equals the radius squared. And a lot of times people forget that after we learn ellipse and hyperbola, they want it to equal 1. And it doesn't. For a circle, you don't have fractions. It equals the radius squared, okay? But for an ellipse and hyperbola, ellipse is 1 plus the other equals 1, and hyperbola is 1 minus the other equals 1. But it's all just completing the square and then getting equal to 1 for both of those. All right? Okay, so let me give you the homework for 7.5, and y'all can go ahead and start on it. And I can give you 7.6 homework, it just won't be due until Wednesday, if you want to do it that way. Okay? You can start on it if you get time, but otherwise it will just be due Wednesday. Recording stopped. I don't know how to stop recording.